NASA's Jet Propulsion Laboratory in Southern California. I'm Raquel Villanueva. The Ingenuity helicopter is now standing on its own on Mars after hitching a ride to the Red Planet on the Perseverance rover. Today, we are looking ahead to Ingenuity's takeoff with some of the members from the Mars helicopter team who will be answering your questions. Ingenuity project manager Mimi Aung will join us later. With us now is Ingenuity Deputy Operations Lead, Teddy Tzanetos. Teddy, thanks for joining us.
Thank you for having me.
Remember to use the Mars helicopter hashtag to ask a question. So, Teddy, can you walk us through how the Mars helicopter was able to stand on its own?
Sure. So the whole team's super excited right now. We just got through a lot of huge milestones now that we are in our official helicopter mission phase. To get to the point where we're standing on all 4 feet required a lot of intricate deployments from the rover, Perseverance. Since launch, we've been in the belly compartment of Perseverance, so underneath the deck. And after we went through EDL, since arriving on Mars, we've been staying there, getting charged periodically, kept warm from the energy from Perseverance. But we just completed recently our deployment sequence where we've been unfolded, our legs have been deployed, we went vertical, and very recently we were just dropped onto the surface for the first time. And now we're on our own. We're a separate spacecraft on Mars, on our own energy, and the team couldn't be happier.
What was it like seeing that first image of it on the surface of Mars?
Oh, it was it was a dream come true. To see the culmination of the entire team's hard work really pay off. Being dropped, right? That's one huge milestone. But the massive one for us over the last 2 days has been realizing not only did we drop, but we actually survived the first night. That is huge. That was one of the huge achievements that we've been looking forward to. And now we can move on to the rest of the mission. But being able to drop under our own energy, sustain ourselves, keep ourselves warm throughout the night, and then wake up and talk with Perseverance and say, yep, we're here, we're alive and healthy, the team couldn't be happier.
Now, you said this was a dream come true. Could you kind of talk us through your career path, which led you to eventually be on the Mars helicopter team?
Sure. Ever since I was a little kid, I've been infatuated with computers, electronics, robotics. My dad got me started at about 8 to 9 years old, playing with robotic components, playing with some sewing machine parts, and eventually taught me how to build my own first computer. From there, it kind of snowballed, and I went to study computer science and electrical engineering for undergrad and graduate school, and from there on, I was hooked. Anytime that I saw something doing anything on its own autonomously, I want to know, how does it work? I want to take it apart. I want to figure it out. After graduate school, worked a couple years in the field, and then was eventually lucky enough to land a job here at the Jet Propulsion Laboratory to work on once-in-a-lifetime kind of project like Ingenuity.
That's great. And now, Teddy, this is all the questions I had for you. Can we now go to our social media questions?
Please.
All right. Let's head over to the first question is from, let's see, Deja Sue on Twitter asks, are all Ingenuity rotor blades basically identical, and is it best to say it has 2 blades or 4?
So there are 4 separate blades on Ingenuity, and there are 2 comprising the 2 rotors. So each rotor has 2 blades, one on the top, one on the bottom, and they spin counter to each other. So in terms of are they different, the 2 directionalities of the blades are different, but the aerodynamic designs of them are similar. You'll also note that there are pitch weights, those little pointy things at the root of the blades. Those, obviously, between the upper and the lower are different. But aside from that, the direction in which they're designed to spin and the direction that the pitch weights go, they're effectively the same.
Okay, now, Transit Signal on Twitter notes, it appears that the Mars helicopter Ingenuity has a bit of dust on its solar panels already. Is that a problem?
No. We saw some initial images from the rover. We got some high-resolution HazCam images looking down at a kind of upward angle onto the solar panel. which is great. It's fantastic to see that new imagery. And you can see there looks like there's some dust accumulation. But in fact, yesterday was the first time that we got our noontime Mars solar array characterization, a huge step for us. And the solar array is working perfectly. It lined up right where we had expected it to. And as a result of that, we know that it charged our batteries up right before we communicated with it. So the system, energetically, it's working fantastic. We couldn't be happier.
That's good news. And now Henry on Twitter asks, how is the Mars helicopter protected from a harsh environment, storms, etc.? Can the helicopter be protected by Perseverance?
No. So the mission is designed so that once we get to our flight phase, Perseverance is going to be at a standoff distance, a safe distance away so that we could fly in our flight zone and execute our 5 flights coming up. So there's no notion of guarding against wind or any other effect or dust or something like that. We're on our own, right? And that's part of the challenge. That's part of the excitement of what's to come here. We just, like I said, we just got through our noontime wake up yesterday, but there are important steps up ahead. The next 2 sols on Mars will be doing energy evaluation, wanting to make sure that our thermal models are tuned, our thermal set points are tuned correctly. Inside the gold box here is where all of our precious electronics are and our lithium-ion batteries. And we're going to look at the data from the next 2 days to make sure that they're staying warm well throughout the night, and that by the time the sun rises and we get more photons on the solar panel, we still have enough energy to make it there.
Speaking of the batteries, Valentine on YouTube asks, how long can it fly on full batteries?
Sure. 90 seconds is what we're targeting for the average of our flights. The first flight, though, right, that's going to be the most critical. And right now, that's a simple takeoff, hover, and land back down. But 90 seconds is kind of the averaged flight length that we're looking for. Everything after that first flight, not as critical. That first one's the important one. We are a tech demo, and we want to make sure that first flight works out.
We have more questions about the battery coming in right
Sure.
now. Kira on YouTube asks, what is the voltage and amperage of the battery of the helicopter?
Sure. At 100% state of charge, it's 25.2 volts. So we have 6 lithium-ion cells. Each one at 100% is 4.2 volts. So you multiply that out, you get 25.2. And that, again, that's at 100% state of charge. That fluctuates throughout the day as we use energy to power our electronics, talk back with Perseverance, and then the big chunk of energy goes into heating ourselves overnight.
And that kind of leads us into Celebi on YouTube asks, what extent do cold nights on the surface of Mars affect the Ingenuity helicopter? I assume they're saying, does it affect its lifespan?
So let me break that question up into the separate parts. So
okay.
To what extent does it affect us? Massively, right? Temperatures are huge, and that's what we're spending the next 2 sols on Mars doing, is proving out our models, making sure that we have enough margin to, like I said, come out in the morning with enough juice in the tank, so to speak, yes. To communicate to Perseverance when it's time. So it's a huge focus for the team. Yesterday was a massive success, and again, the next 2 sols are really going to be tuning that in. In terms of the lifetime, the mission lifetime is only 30 sols. So while examples of other robotic platforms that we've sent to Mars, right, have definitely lasted longer than the initial lifetime, our mission is to knock out 1 flight and then 4 additional flights after that within those 30 sols.
You mentioned it's similar to Sojourner.
Exactly, yeah. Just like Sojourner was a technology demonstration for what we have now for rovers, right? We didn't always have large, very capable rovers on Mars. It started off as a technology demonstration that we see here. We hope that Ingenuity will do the same for the future of Martian aerial exploration.
Okay, and up next, that kind of leads us to John's question. On Twitter, he asked, what will the Mars helicopter do? What's its purpose?
So hinted at that earlier. We are a technology demonstrator, period. Ingenuity does not carry any science payloads. We are not a science oriented mission. Our goal, plain and simple, is to prove that we can fly on Mars. Once we do that, we hope that this is going to blow the doors open for the future of Martian exploration. Unlocking that aerial dimension, we think, is going to be extremely exciting for humanity and for scientists within NASA and the larger exploration community. We really think this is going to be that kind of breakthrough moment for us to try out new ways to explore Mars.
And up next, Michael on YouTube wants to know, how high will it go?
So a handful of meters. Especially for that first flight, we want to just maintain, a close range. We're not going to be going for any long-range distances. Like I said, we're just going to take off, hover a couple meters off the ground, and then come back down.
And for American viewers, how much is that in feet?
We're going to go about 15 feet off the ground.
Now, Raf on YouTube asks, did you use open source hardware software just for this tech demo?
Yes, so there's a good amount of open source software. F Prime, which those of you at home can go onto GitHub right now and look at the F Prime repositories that are open sourced, runs Ingenuity. That is the key to all of the software architecture that Ingenuity runs on. And not just Ingenuity, but the base station for Ingenuity on the rover as well. So yeah, huge component of how we operate.
And up next is Pilot Pigo on YouTube says, let's hope a dust devil doesn't come along and knock over Ingenuity before its first inaugural flight. Now, is that scenario possible?
Right. So this question has come up a lot for a bunch of different team members. The way that Martian dust storms and windstorms are portrayed in movies is a little exaggerated. The thing that you need to keep in mind is that the Martian atmosphere is 1% the density of Earth's. There's not a lot of molecules falling around or flowing around in the air to impart a lot of inertia to knock something over. That's not to say that it wasn't looked at and analyzed. Our engineers did look at what are some of the peak wind velocities that we could see on the surface, and how might that pose a risk to us. That's a landed concern, and then there's also the flight concern, right? How do those winds affect us when we're aloft, right? And that's part of the testing campaign, the extensive testing campaign that we did here at JPL. We're lucky enough to have a space simulator, 25-foot space simulator, 25 feet wide, several stories tall, and we built our own Martian wind tunnel in there to test that out, see how does the baby perform in a little bit of crosswind.
So it's not the same image that people might have of a dust devil on Earth
at
all.
No.
All right, Scott on YouTube says, from the photos, it appears that the solar power is, we already took a question similar to that, so I'm going to go on to Terry on YouTube who asks, will you be checking for wind gusts before it takes off?
So we're going to try and characterize soul to soul as best we can the environment leading up to first flight, but there won't be an instantaneous pre-flight check for wind gusts. The way operations works with Mars is we need to kind of send the signals up, we go to bed, and we wake up the next day and find out how things went. So there is no notion for flight operations of being able to do an immediate lifetime check like that.
And then up next we have Barat on Twitter asks, is it going to be possible to watch the Mars helicopter while flying?
I guess there's two ways I guess that question may be meant to be phrased. So you can follow along with us after we downlink the telemetry and later on some images, but that won't be live. Like I said, that'll again be the sol after, or several sols after we fly to get all that telemetry back. There's also the component of what will Perseverance be doing. We're going to try to get some images from Perseverance's perspective of Ingenuity when we're in flight as well. But again, that won't be live.
What will it be like for you watching and waiting for?
That'd be probably one of the most nervous moments of my life, and the whole team. We're going to send that sequence up the night before, and knock on wood, we're going to cross our fingers and hope that everything goes the way that we've tested and planned and tested again. But there's no telling, right? Space is hard, so we're gonna see how that first flight goes and then build off that.
Well, we definitely have our fingers crossed for you. Knocking on some wood. That is all the time we have for questions today. Thank you so much for joining us,
Thank you very much. Appreciate it.
Thanks. I'm going to have you step back, and we're going to actually sanitize the chair for Mimi to come step in. So while we wait, remember that you can send in your questions using the Mars Helicopter hashtag, and when we're ready, we will get to Mimi. You can come step over now. Hi, Mimi.
Hi, good morning.
Good morning. So, how does it feel? How are you doing?
As Teddy said, our team is over the moon, very happy. Not there yet, so we're very happy about where we are so far, and it's been wonderful. So Perseverance rover delivered us with its Mars Helicopter Delivery System, MHDS, perfectly to the ground. Ingenuity woke up exactly as designed, 2 hours, 15 minutes later, took a couple of pictures, went back to sleep, and last night we got the first set of data back. So we couldn't be happier, but cautiously happy. Many, many steps between now and the first flight.
Can you get into what are those next steps coming up?
Yeah, so the next step, really today and tomorrow, really fully confirm this energy thermal model. And you know, the whole interview has been about energy and thermal at the end of the day, because if we don't have enough energy, you know, we can't fly and we can't survive the night. So we're carefully taking more temperature data, the battery state of charge, and really looking at the current, you know, coming in from the solar panel and confirm. And we will use that information to actually optimize the time to fly the helicopter. We really want to fly it when the battery has charged up fully, and then we want to fly early enough so that after the flight we can charge again before the evening arrives to be ready to survive that long, cold night. So we'll be doing that the next 2 days, and then we will be ready to start turning our attention to the rotor system. And so the first thing we'll do in about 3 days is, and 3 sols, I guess, Martian days, 3 sols, is to release the blades. The blades are being held right now with the blade pitch restraint. That's why they are now pointing straight north-south right now, and we will be ready to release them. And that takes rotating the blades in the same direction instead of counter-rotating in the same direction just for a fraction of a cycle, and that will release the blades. Major deal, the blades have to be fully released, and then we will wiggle the blades the day after that and do a very slow spin, 50 revolutions per minute, and that will confirm that our motor control, the servo controls are the way we've designed it. And then lastly, still on the ground, we're going to do a full speed spin, approximately 2,400 revolutions per minute. Full speed spin to fully check out without taking off, check out the rotor performing. At that point, we'll be as ready as we can be, and we'll take 1 day to, again, fully charge the vehicle to maximize probability of success for that very, very first flight, the most important first flight, and then we go for the first flight.
You've been mentioning sols. How are they different from Earth days for our audience at home?
Sure. A sol is about 39, about 40 minutes longer. The Martian day is about 40 minutes longer than Earth's day. So all the events of the helicopter activities are timed at the Martian time. And so Teddy had mentioned just now, you know, we took measurement at noon yesterday. And then, for example, today we're looking around 2 p.m. Martian time. And so events happen at Mars following the daytime at Mars. And then we stay awake just following the Martian time on Earth. So,
well, this helicopter has certainly been on its journey. I wanted to talk to you about your personal journey. Can you kind of explain your career path and what led you here to eventually work on the team?
Sure. I came to NASA's Jet Propulsion Laboratory, JPL here, 30 years ago. And I've always been in the deep space exploration. And the first thing was to write the signal processing communication algorithms to track these tiny, tiny weak signals coming from deep space, right? And in fact, we have now spacecraft that are out that have left our solar system, right? Like the Voyager. Anyway, so we really working on the algorithms, and when Deep Space Network was upgrading the receiver, making the first digital receiver to track the signals from there. So that's how I started at JPL. And over the years, I transitioned over to the spacecraft side and got involved with just spacecraft design and systems. And specifically, over the last 15 years, a little more than that, I have really fallen in love with increasingly autonomous capabilities of space systems that we need to develop. So we have wonderful, orbiters, landers, and rovers, but there is plenty of room for spacecraft to be more autonomous, being able to function and make decisions on its own and explore more autonomously. So that's the area that I've been dedicating myself to. Along the line, Mars helicopter came along, and that's an ultimate autonomous machine. And so here I am. And so about 6.5 years ago or so, I jumped in and joined the Mars helicopter effort, and it's been wonderful.
Wow. Was it an interest you always had as a child, or when did you know you wanted to get into this? I grew up in Asia. I was born here while my parents were getting their PhDs at the University of Illinois. But after they received their PhD, my formative years were in Myanmar, and then also in Malaysia, and then I came back when I was 16 years old. So having grown up in other part of the world, it wasn't like I had a direct dream. I've always been fascinated with space. Mm-hmm. I mean, you can see stars and the fundamental questions of, is there life there? Are we alone? That's something, that question just runs deep inside of me. I mean, it runs deep inside of most people, right? It's the ultimate question of humanity. Are we alone? But I really didn't know if I would have the opportunity to be a part of NASA space exploration. So always dreamed, but didn't know if I could get there. But one step at a time, you follow the path to education. I came back to the US, followed my educational path, and ended up at JPL. And I think the realization was when I finished my master's degree in electrical engineering, it was time to interview for jobs. And then one of the professors said, NASA JPL, they have these extremely large antennas with very low noise amplifiers, extremely lowest noise temperature amplifiers, possible to really be able to track the very weak signals. And then all the old dreams and the current moment clicked together. And I did everything I could to get an interview at JPL, and got the interview and was hired, and it's been a dream ever since. Well, you're certainly doing a lot to inspire the future generations. Those are all the questions I have. Now we're going to get to some social media questions, if that's all right. First up, we have Wilson on YouTube asks, what does the Mars helicopter sound like?
Oh, well, the helicopter is a very high power operation. I mean, the peak power of close to 350 watts, it's a very high power operation to spin 2,400 revolutions per minute, even in the thin atmosphere. Mm-hmm. So if you have seen some of the test videos out there, it can be quite loud in the test chamber that we have, because it's an enclosed room, right, that we have pumped out most of the air and then pump back in with carbon dioxide to simulate this approximately 1% of the density compared to Earth's, right? So in the chamber, it's extremely loud. On Mars, in open space, there are a lot of debates and guessing, how audible it would be. So I think it would be difficult to hear if you are standing on Mars with a flight, that's 50, 100 meters away. But it sure is high power, and you can definitely hear it very loudly in the test chamber here.
Well, that will be exciting. This next one, we might make use of our helicopter model. Alex on YouTube asks, why is there a little hole on one of the feet on the helicopter?
Oh, yes. So very good eye, and it is not on this model for a very good reason. When we built the flight model, Ingenuity, this is the copy that's at Mars, right? Ingenuity itself. The feet were all the same. Mm-hmm. And then later, after the helicopter was developed, we started designing, the rover team started designing the Mars helicopter delivery system on how to hold the helicopter under the belly pan, and really to minimize protrusion of like a helicopter hanging down under the belly pan. Instead of hanging vertically, the helicopter was stored sideways, with the blades aligned, and restrained, and the legs actually pulled back and held by some systems that later released a few days ago, right? So in order to hold, it turned out one of the feet had to be redesigned to match the Mars helicopter delivery system. So in that sense, that's why one of the legs is different. But also, all the legs we actually of the Ingenuity were retrofitted, because in order to fit into the MHDS, the legs actually had to be capable of bending back and be held like that for over a year, right, since before launch, and have springs in them and have flexures so that after being held, when they're released, they still have the tension to snap down and latch and see the legs come into the position that they have done. So it looks very simple, but there is quite a bit of mechanical engineering in this late edition, and so that's why they're a little bit different. And that's why we're extraordinarily happy when the legs came down, and we knew that they latched, and they're standing, exactly, the helicopter is standing exactly the way it was designed for.
Yeah, every milestone is very important. All right, up next we have Patrick on YouTube who asks, why was the flight date postponed to April 11th?
Oh, yes. So, I'm going to give a very long story. This is the first ever test experiment on Mars. And, it's a very, very rare opportunity that we are extremely protective about. So, short answer is to be extremely careful. And so we were originally targeting April 8th to fly, and we moved it to April 11th for two reasons. One, when we were getting ready to drop the helicopter, the MHDS had rotated the helicopter to a vertical position, and before we dropped, we also wanted to take the time to make sure that under some harnesses under the belly pan of the rover, that they were going to be clear, now that we're on actual terrain, the rover's on actual terrain, that when we drop, you see this little antenna here that's sticking up here. Yeah. Looking at the images that the rover's Watson camera had taken, we wanted to make sure that the little antenna sticking up wouldn't catch in harnesses or anything else under the rover on this actual terrain, that there is no chance of it snagging. And so we wanted to take an extra time to look at that. And that's the first one. And then secondly, for this energy story, we decided that after the drop, we wanted to add extra days to make sure that we can actually characterize the energy story and make sure the solar panel is charging the way we think it is, and the hour-by-hour profile of the energy, right? As you're charging up, expanding the energy, charging up again, that our energy is positive throughout all of the day. So everything is healthy on the rover's deployment side, helicopter side, but we really decided together to take care. So,
wow. Well, thank you so much for joining us, and good luck this week. I'm very excited for you. I hope you're excited as well.
Absolutely, lots of milestones ahead that we are looking forward to, and learning from every single step ahead of us, all the way up leading to the first flight.
Well, thank you, Mimi, and thank you for your social media questions. So for updates on Ingenuity, follow @NASAJPL and use the hashtag MarsHelicopter to keep asking your questions. Also visit go.nasa.gov/Ingenuity for images and videos and upcoming webinars. In fact, there's one starting right now. Thanks for watching.